Let's consider what happens with divergent lenses. Now the shape in this particular one is double concave. As you see it, we have a concave surface here and a concave surface here. Now we are shining one light beam from the left. Once it meets the first interface between the outside, which is air in this case, and the glass, then it's going to bend. Again, the angle of incidence is going to be relative to the perpendicular at that point. So this is my angle of incidence. So my beam, instead of continuing straight, is going to bend towards the perpendicular, since we are moving from a low index of refraction to a high index of refraction. And then it's going to continue straight within the glass till it reaches the new interface, glass-air interface. Again, it's going to look for the normal at that point. We have the line there showing the normal. And in this case, since we are moving from a high end to a low end, the beam is going to move away from the normal. So in both cases, the deflection of the beam is going to move it away from the principal axis. So eventually the beam is going to look like coming out away from the principal axis. Now, if we kind of trace this beam back through the lens, that beam is going to look like coming out of the focal point. Now, let's look at some other representations of this. Let's take this one here, where we have our object represented by several beams of light coming from different locations along the object. And you notice here the light coming out of the divergent lens is not going to meet anywhere on the right side of the lens. The light is not going to converge here to produce an image for us, but it's going to look like it's coming from a certain image in this side, and we are not showing that image right now. Now let's look at another representation. Now in this particular case, we have only the parallel beams of light, and you notice as they emerge out of the lens, they all look like they're coming from a virtual object somewhere here close to the lens. Now notice that no matter where I place my object, we always get that virtual image. It's not going to depend on where the object is. Its position and size would depend on where the object is. But the fact that it is virtual and upright is going to be correct all the time. I'm not sure how well you see it. It's a little hard to see, but this is our image.